My name's Mark Billingsley. I'm a trainer with TOPCON University. I'd like to introduce you to the new PS series robotic total station with several key and unique features to TOPCON. The first of which is TS Shield for security, Long Link, which is long-range wireless communication, the ability to have magnet field software on board the total station, the ability to run magnet field software on a variety of different controllers, and furthermore utilize cloud technology to send that data from any of the field controllers back to the office and view that data real time back in the office. All these features make the PS an outstanding robotic solution unique to TOPCON. So what I'd like to do now is show you some of the real world tests that we've done with the PS robotic total station in comparison with the competition.
So the purpose of this test is to test the reflectorless performance between the TOPCON, the Trimble and the Leica. The scenario that we have is we have a building across the street that's approximately 315 feet away from the instrument, and then we have a panel fence that's in front of the building that's approximately 213 feet away from the instrument. The object of the test is to sight the fence and then shoot through the gap in between the fence panels, which is approximately 5/8 of an inch, and compare the results between the instruments. So the tests with the Trimble S6 proved when we measured to the fence panel and the gap between the fence panel, we got repeatability over 3 separate measurements on the same distance. The other issue I found in using the Trimble S6 was due to the mag drive, the sensitivity was quite difficult in sighting the gap in the first place. And the final issue was using the Trimble TSC3, which is completely separate to the Trimble S6. Once you've taken the measurement, you then have to come down to actually look at the screen. So the first issue I found in using the Leica TS15 was it was very difficult to center the instrument over a nail, because using the laser plumb in sunny conditions such as these, you cannot see the laser. The tests for the distance measurement to the fence and the building behind the fence did not distinguish the correct distances. In fact, the distances proved to be erratic and didn't give true values for either measurement. So having used the TOPCON PS for reflectorless measurement, I found that the instrument was extremely consistent and reliable, first of all in measuring to the fence panel, and second of all in sighting through the gap between the fence panel onto the building behind. The distances were consistent and the speed of the EDM was extremely quick. So in conclusion, having tested all 3 instruments, the TOPCON, the Trimble and the Leica, I found the TOPCON working in reflectorless mode outperformed the competition. The speed and the reliability of measuring to the fence panel and the building through the fence panel was completely consistent and reliable on 3 separate measurement tests. So the purpose of the task that we're about to undertake now is to check the predictive tracking of each of the instruments, the TOPCON, the Trimble and the Leica. We're going to take the rod and pass it behind several objects, which are going to be trees in a field, and see how well each of the instrument, number 1, tracks the actual rod itself, and number 2, how, if we do lose the rod when we pass behind the objects, how quickly it reacquires. So we have different technologies across all 3 different instruments. So we can use passive target tracking, we can use active target tracking, and we can also use GPS search. The key thing is, number one, how well does the instrument actually predictively track the target or the rod? And number two, if it does lose it, how quickly does it reacquire it? So having completed the test for predictive tracking, you can now see how the TOPCON, the Trimble and the Leica are able to track the targets as they pass behind objects. You've seen that the TOPCON is superior for the predictive tracking as the rod passes behind the object and the instrument is able to accurately predict the movement of the rod as it passes behind and reacquires it. And if the rod does get lost behind the object, reacquisition of the target is a matter of seconds.